Now, whenever we have two displacement vectors added together in this way, we can draw a third vector that represents the sum of the two vectors. So reproduce this diagram down here. Draw, that's 4 miles to the right. So that gets you from one point to another. And then 3 miles up. That's really 4 miles east and 3 miles north. So draw those two vectors. And then we can draw a third vector. And the third vector represents the sum of those two. The third vector should go from the very beginning of the hike to the very end. So the third vector goes like this. And make sure you draw the arrowhead on it, and it needs to be pointing the correct way. It's pointing from the starting point to the ending point. So it's pointing this way. This third vector that I've just drawn represents the sum of the other two. That is the vector that I get when I add the 4 miles east and the 3 miles north. And there's some important things to note about this. One is that when I add two vectors, I get another vector. And that makes sense. Just like adding two numbers gives you another number, adding two vectors gives you another vector. We actually have a term for it. It's called the resultant. Just like adding two numbers gives you what we call a sum, adding two vectors gives you a resultant. It basically means the same thing. The resultant is the sum of the two vectors, but we call it the vector sum. Specifically, the resultant has a direction. You don't get a direction if you just add two numbers. If you add 10 and 5, you get 15. There's no direction. But if you add two vectors, the vectors inherently have direction, and so does the resultant. Now, the other important concept to note here is that the resultant vector, let's go ahead and label it. Let's call it R for resultant. The resultant vector is equivalent to the original two vectors together. In other words, if I hike 4 miles to the east and then hike 3 miles north, the end result, getting me to this point, the end result is the same as if I had hiked this far in this direction. So the resultant by itself would be equivalent to the two original vectors added together. And this fits with our intuitive understanding of what addition is. We know that if we add two numbers, like if I say 2 plus 4 is equal to 6, I know that my answer here, the 6, is equivalent to the original two numbers together. If someone gives you $2 and someone else gives you $4, then that is the same end result as if someone had given you $6. In the same way, if you hike 4 miles east and then hike 3 miles north, the end result is that you're at this spot. The end result is the same as if you had hiked this distance in this direction. So the resultant vector by itself is equivalent to the original two. And the resultant takes the direction into account. You can tell that if you hike 4 miles to the east and 3 miles north, you end up at a point that is northeast of where you started. And not only is it northeast, but in this case it's a little bit more east than to the north. And this resultant vector takes all of that into account.